What we're gonna do in this video is take our understanding of logic to the next level. So far, we've talked about simple propositions, sentences like, "it is raining," or "2 is an even number," which are either strictly true or false. But what if we want to talk about groups? If I say, all students in this classroom passed the exam, or some basketball fans support the Lakers, our propositional logic starts to break down. We need a way to handle variables and generalities, and that is where predicate logic comes in. Now, let's do a quick refresh. A proposition is a declarative sentence that has a definitive truth value, like we mentioned before, such as "it is raining" or "2 is an even number." But look at this sentence. X is greater than 5. Is that true or false? Well, we don't know yet because we don't know what X is. So we consider this as sentences with holes in them. In logic, we call these open propositions or open sentences. An open proposition or open sentence is the actual statement containing variable that has no truth value yet because the variable is unspecified. And by substituting value in the variable, we can turn open proposition to a proposition, since the variable's value will give the statement a tendency to have a truth value. For example, let's take our prior example. If I substitute x with 10, for example, then the statement 10 greater than 5 becomes true, and it becomes a proposition. If I use 2, then 2 greater than 5 becomes false, which is also a proposition. So we just saw an open proposition being turned into a proposition by substituting value into the variable. The same applies to English-based variables. If I say X is a student in a New York classroom, the truth depends entirely on who we pick for X. As soon as we pick who X is, the statement becomes proposition by either being true or false. All right, now that we understand what open proposition is, to make this formal, we use predicate notation. Predicate is the rule or property, often represented by a symbol like P of X, that defines that open proposition, while open proposition is being the statement itself. Instead of writing the whole sentence every time, we use a capital letter followed by the variable in parentheses, like P of X. This is similar with when we represent a proposition with a lowercase letter. For instance, we could define S of X as X is a student in California, or V of X as X is a registered voter in the USA. The notation P of X is the predicate, but it isn't a full proposition yet because it doesn't have a truth value until we either plug in a specific name, which is substitution we've seen earlier, or another method for turning an open proposition into a proposition is to add a quantifier. So let's see what quantifier is. What are quantifiers? Quantifiers are the tools that turn open sentences into complete logical statements without substituting value onto the variable. There are two types of quantifiers, which are Universal Quantifier and Existential Quantifier. Let's see them one by one. The first is the Universal Quantifier, symbolized by an upside-down A as shown here, which stands for all or for every. Let's think about this together. If I want to say all students in this classroom submitted their homework, I'm saying that for every individual X in the domain of this classroom, the property of submitted homework is true. Symbolically, we'd write as such, all X P of X, where P of X stands for the open proposition and the universal quantifier stands for the word all. Let's see another example. We have a statement goes as, every employee in the company has an ID card. So our predicate can be expressed as S of X implies I of X, where S of X is an employee in the company, and I of X will be X has an ID card. Hence, the proposition can be expressed as, for all X, S of X implies I of X, where the universal quantifier stands for the word every. The first example can also be expressed as such, where we can say C of X being X is in this classroom, and H of X being X submitted the homework. Therefore, the statement all students in this classroom submitted their homework can be expressed as, for all X, C of X implies H of X. The second tool is the existential quantifier, symbolized by a backwards E, which means there exists, or at least one.
If I see just one person in a crowd of students wearing a red shirt, I can say there is at least one student in this classroom wearing a red shirt. Even if there are 50 people and only one fits the description, the statement there exists X, Px, is true. The core point you need to capture is, for the existential quantifier to be true, you only need to find one, and for it to be false, none has to be found in the domain that satisfy the statement. Let's see some examples. Here the statement says, some students play basketball. Here the open statement is composed of two predicates, which are S of X being X is a student, and B of X being X plays basketball. To express predicates, you can use any letter as long as it is uppercase. So me saying B of X or S of X is an arbitrary use of letter. All right, let's get back to our example. So after determining the predicates, we look at the quantifier indicative word, which is some, and this implies at least one that satisfy the case. Therefore, we use existential quantifier, and our proposition becomes there exists X, S, and Bx in parentheses. Notice that we used implication for universal quantifier in conjunction for existential quantifier. And you might wonder why. The reason is that if all the members in the specified domain satisfy a certain condition, such as in our prior example, all the students submitting their homework, then being a student becomes a sufficient condition for submitting homework. Hence, we say for every person X, if X is a student, then X submitted the homework. It is true for all students, so if one is a student, then we can say one submitted the homework. Therefore, implication is the right one to express it.
But for existential quantifier, or if some students submitted the homework, then being a student isn't necessarily mean you submitted the homework. Rather, there is some individuals, though, who are a student and submitted their homework. So since we're talking about a specific member of the domain who satisfy both cases, we use conjunction instead of implication. Therefore, we say there is at least one student who submitted the homework, or there exists X, where X is a student and X submitted the homework. You might ask, what if I use conjunction for universal quantifier? And that's a good question. The only reason we can't use conjunction is because the meaning goes beyond our scope, since universal quantifier is a general quantifier. Let's take the same example. If we say for all X, C of X and H of X, then what we meant will be no matter what X is a student and X submitted the homework. It doesn't matter X is a person, an object, or an animal. Notice the meaning shift? Since we can substitute anything for X, the statement will be boundless. Therefore, we use implication instead of conjunction, because conjunction is a bit stronger. All right, let's try translating some real-world examples into logic. First up, we have a statement, all American citizens have a nationality. As we can see, the statement starts with the word all, so we use the universal quantifier, all, and we use an implication connective here. Therefore, the logical expression of the proposition becomes for all X, C of X implies N of X, where the predicate C of X stands for X is an American citizen, and N of X stands for X has a nationality. Okay, let's see another one. Here, the statement says, some basketball fans support the Lakers. Pause the video and try to do this one. All right, since it's some, we use existential quantifier, and we use a conjunction because it's an existential quantifier. Therefore, the expression becomes there exist X, F of X, and L of X, where F of X stands for X is a basketball fan, and L of X stands for X supports Lakers. I hope this is clear. Let me know in the comment if you find any of it challenging. Before we wrap up the video, let me leave you off with a couple of exercising statements for you to practice and solidify your understanding. Let me know in the comment section if you find any of it difficult. And we're done. Today, we learned that while propositions are the building blocks, predicates and open sentences allow us to use variables. We use universal quantifiers for everyone and existential quantifiers for at least one. Hopefully that makes some sense and helps you feel more confident with symbolic logic. If this walkthrough was helpful, hit that subscribe button, and I'll see you in the next Rimetric walkthrough. Thank you for watching, and see ya!